Hi everyone, I'm Lupin Liu. Very glad to have this chance to introduce our work, Pseudo Numerical Method for Diffusion Model on Manifolds. We first introduce some basic idea of diffusion models. Diffusion models transform the data distribution from Gaussian distribution to image distribution through an iterative process. This picture is a good illustration of this process. However, this process needs hundreds to thousands iterations to finish, which is slow. Our work focuses on making this process faster. Our method do not need additional training, do not need schedule adjustment, do not have dataset limitations. Use pre-trained models, we achieve better FIDs and 20 times acceleration at the same time. This picture shows FID result of our method and a famous paper DDIM. We can find we achieve the best FID of DDM using only 50 steps. And our best FID is much lower than DDM. In fact, we achieve shorter FID on the dataset CelebA A. Why our methods work well? We show some motivations. Several previous papers have shown the denoising process can be treated as an ordinary differential equation like equation 1. However, when we directly use numerical methods on this equation, we find the results are limited. For example, when we use the first order Runge-Kutta methods, this method can get worse result than first order DDM, which is abnormal. And what happened here? In our paper, we find two main problems of using numerical methods directly. The first problem is that equation 1 contains a neural network which is well defined in a limited area, namely the area containing training data. Where equation 1 is unbounded at most cases, where the classical numerical methods all require the ordinary differential equation is bounded. We also need to explain why DDM can work better. We compare the first order classical numerical method and the classical first order DDM. We find that classical numerical method can only generate a result along a straight line, while DDM can generate a result along a curve. This curve helps generate results based the training data better. And in our paper, we find we can use this curve not only in first order method, but can apply this curve on higher order numerical method. We can change the linear multi-step method like equation 4 to equation 5. We call this new method pursue linear multi-step method because we can find we have changed the generate curve from straight line to the curve of DDI. And why this chance work well? We found our method PNDM have a third order local error and a second order convergence, while DDM are only first order convergence. This helps our method not only faster than DDM, but get better FID. According to our experiments, we find that DDM can generate results better and better, but this process is slow. While classical numerical methods, namely FON, can generate results faster, but we can find the general result contain noticeable noise. Our method PNDM solves the problem of force of sum, which is faster and better. Thanks for your attention. That's all. I'm Lupin Liu. If you have any advice and problems, please without hesitate to send me an email. Thank you.